Welcome to the Social Science Data Lab. We're very happy that Clara Müller is here today and will present about when events change samples, disentangling causal effects from compositional bias in quasi-experimental designs. The Social Science Data Lab is an event series here at the Mannheim Center for European Social Research where scholars present tools and methods for the analysis and collection of data in the social sciences. Our speaker today, Clara, is a PhD researcher here at the University of Mannheim. She holds an MA in political science from Mannheim and a BA in philosophy from the University of Tübingen. Her research lies at the intersection of political psychology and quantitative methods. In particular, she focuses on how political contexts affect not only political behavior, but also the quality of survey data and what this implies for survey-based measurement and causal inference. And this will be also part of her talk today. Just some housekeeping. As always, we are recording this event, this live stream in active speaker mode. This means that the audio from on-site participants and online participants will be recorded. And for those of you online, if your video is turned on while asking a question, your video will be recorded as well. Clara, thanks for being here today.
Yeah, thanks so much for having me and for the introduction. Also nice to see many faces here on site. I know there are also a few people online. I don't see you, but also welcome to the talk. Yeah, as Alex said, I'm currently still a PhD researcher here at the University of Mannheim. And what I'm presenting today is some part of my PhD thesis, specifically one paper I've been working on most recently, but I'm also going to give you a little bit of a, let's say, broader overview of some concepts and more theoretical notions that I've also been working on in the past few years. So this is specifically on kind of, let's say, a suggestion I make or an approach to disentangle what I call compositional bias or compositional effects in natural experiments and quasi-experimental designs. Maybe generally, I'm gonna also in a second give you an overview of what's going to happen today, and there will be in between some breaks for questions, discussions. I'm happy to hear your thoughts and ideas. But also, if you have anything that's popping up throughout or clarification questions or any thoughts you want to share, feel free to just shoot them at me. I'm happy to be interrupted. Also, if people online have some questions. So the whole motivation for that is coming from the fact that empirical social science research heavily relies on survey data. I'm pretty sure all of us have worked with some kind of survey data before of different kinds of structures. And it's quite known and no secret that survey data do not perfectly reflect citizens' true preferences. For different reasons, it could be that people just do not truthfully report their true preferences because of certain pressures, like social desirability biases, for instance. But we also know that some people are just more willing to respond in surveys in general. So, for instance, we know that people with higher levels of education, for instance, are way more likely to be participating in surveys, or people with higher levels of political interest, if we talk about like political or social surveys in general. And besides those differences in survey responsiveness across people, it's also the case that the survey responsiveness within a person can change. And from survey research, we know that changes in people's, let's say, more narrow personal context, like employment situation, household composition, moving, for instance, can change how easily they can be reached or how likely they are to participate in the survey once they are sampled. What has been much less researched, however, is how the broader and more political context does affect the survey responsiveness. And borrowing from political behavior research, we know that political events and changes in the political context does indeed affect people and does affect their political preferences and attitudes, for example. And what I do here in my whole thesis, and specifically also in this talk today, is that I bridge those two perspectives. And I assume that survey participation has some form of political quality and can be understood maybe as a, let's say, soft form of political participation. And that leaves me with the question whether political events can actually also change how likely people are to participate in surveys. So this is the first guiding question that will kind of lead us through the talk today. And if that was the case, the second question arises, how event-induced shifts in survey participation and response behavior could then affect the accuracy and validity of measurement and also causal inference. So I'm approaching this today in 3 steps. The first one is that I want to give you some intuition on non-response bias in general, to give you an understanding of what kind of non-response is actually problematic and what non-response maybe might be less problematic and can be ignored even. And then I'm also going to guide you through my understanding of how political events can induce non-response bias. In a second block, we're going to focus on what I call the compositional bias that arises if people become more or less responsive after events, and specifically introduce you to the very hyped and trendy unexpected events during survey design, which will be in focus of this talk. And we'll give you, let's say, we're going to have a little bit of a conceptual or formalization detour. It's not going to be too extensive, but I want to give you some formalization background on causal and compositional effects. And then I'm going to make my proposal of a framework of how we can tackle compositional bias, both regarding observable factors, but also regarding factors that might be unobservable or unobserved, at least in the data we use. And then in the third block, I'm going to apply the framework to a pretty prominent example of the Charlie Hebdo terrorist attacks in Paris in 2015 and the rally round the flag effect. And depending on time, depending on how much we discuss, depending on how many questions you have, I will also guide you through a replication analysis where I, in a broader manner, apply this framework to published studies. But that's, depends on how long everything else will take. For now, are there any questions on the general setup? Or maybe also something that immediately pops up where you think you would want to have a specific focus on? I'm happy to adapt. Okay, because if not, let's dive into some intuition on non-response bias. So the thing is not all non-response is problematic. And what is decisive in non-response being problematic or not problematic is how responsiveness is correlated with an outcome variable of interest. So it's very case specific. So let's assume that every person has some latent responsiveness, and every individual is located on this latent responsiveness scale. Some are so unresponsive, they will never participate in a survey when they are sampled. And maybe some are so responsive, no matter what the context is, they will just always reply. And for reasons of simplicity, let's just assume that whenever someone is on the positive side of that scale, they will participate in a survey once sampled, which means that they will be one of those observed outcomes. So those solid dots are observed outcomes. Those hollow dots are unobserved outcomes in the sample. Now, in this ideal case, there is no correlation between this responsiveness and the outcome variable of interest, which means that the non-response located here on the left-hand side can be considered ignorable. It's not problematic because the sample of responsive people that you have in your survey data still perfectly reflects the population mean. So one example could be, I mean, this is completely made up, but hair length or body height could be something you could come up with there where we might expect that there is no correlation. I don't know if that actually empirically holds, but just to give you some substance on that. Now, in another case, there could be a correlation between responsiveness and the outcome variable of interest in a way that the observed sample has a higher level of the outcome variable as compared to the population mean. And any measurement of Y based on that responsive sample here on the right-hand side will overrepresent the level of Y. So one thing which is pretty established in the literature, for instance, could be to consider political interest as the outcome variable, because we know politically interested people are more responsive, more likely to be represented in the data. Now, if we know how the correlation between responsiveness and the outcome variable is, it is possible to statistically adapt for those patterns by, for instance, weighing certain observations. But truth is, oftentimes it's just unknown what the true population mean is, and therefore it's also difficult or impossible to actually know how much the difference or what the difference between the population and sample mean is. Now, departing from that, I argue or I expect that certain external treatments or stimuli can change the association of responsiveness with the outcome variable. But first, there's kind of an ideal case. So let's assume some event happens. Say, let's stick with terrorist attacks because it's also going to be the example later. Let's assume a terrorist attack happens and there is a true preference change. There's a true change in the outcome variable, which would kind of look like this. Let's assume the outcome is anxiety, the level of anxiety. Before the terrorist attack, there's a certain level. We don't have any correlation between responsiveness and anxiety. And after the terrorist attack, everyone just feels a little bit more anxious. So the correlation stays unchanged, but everyone raises their level of anxiety. And in that case, our sample would perfectly reflect this true, I mean, I don't know whether you can consider anxiety to be a preference, but a true change in your outcome variable. Now, in another case, it could be that the political event induces some bias in a way that the event changes the association of responsiveness with your outcome variable. Whereas before the event, there was no correlation or a smaller correlation. And after the event, the correlation changes. And there is a change in the outcome variable, or there appears to be a change in the outcome variable that doesn't actually reflect a true preference change. So one example, for instance, could be, again, sticking with terrorist attacks, that after the event, people who are more approving of the government, let's say, if we assume that the outcome variable is government approval, they are more likely to respond because maybe those who are already disapproving of the government, they are so fed up by how the government is dealing with that attack, they for some reason are too fed up to participate in the survey. So they don't end up being in the sample. Whereas those who are more approving in general end up being in the sample, and thus the level of government approval is overestimated, even though it wasn't changed to that extent by the event. And of course, both those perspectives that I'm presenting are an abstraction and like a huge simplification, but they are there to give you an intuition on how I expect events to change survey participation. And of course, true preference change and this bias can occur at the same time. So it could be that actually government approval is increased, but it could also be that more approving people are more likely to end up in the sample. Okay, that for now. Are there any questions so far on that, or anything I could clarify, anything you maybe disagree with, or? Okay, then let's dive into the second block on compositional bias in event study designs. Because what I have described here is what I will refer to as compositional bias, that due to an event, the composition of the sample changes. And I'm focusing on what I hinted at in the beginning, the unexpected event during survey design. And I'm pretty sure many of you are familiar with that. It's become increasingly popular in recent years because I would say it's pretty straightforward and quite appealing, but it also comes with very strict assumptions to allow for causal inference, which I will talk about in a minute. So this design leverages the, as the name says, unexpected occurrence of an event during the survey field time, treating this event as a treatment and having the whole setup as a natural experiment, where pre-event participants are the control group and post-event participants are the treatment group. And then usually, I mean, depending on the structure of your outcome variable, but usually the difference in an outcome variable of interest between the pre and post-event group is taken to resemble then the event's effect on your outcome variable. Now, to allow for causal conclusions with this design, in an ideal case, to get a true causal effect, we would be able to observe the same individual before and after the event. So there's a potential outcome a certain person has in Y before the event and after the event. And if that was the case, as it is, for instance, in panel data, we could estimate a true causal effect by just subtracting the pre level of Y from the post-event level of Y. However, this is not the case. Each individual in this design is either observed before or after the event, but never at both points in time, which means we need to rely on the average treatment effect, which is estimated basically using the difference in mean outcomes from the post and pre-event sample. So here we have the post-event average subtracted with the pre-event average in the outcome variable. However, for this to actually work with the unexpected events design, some pretty strict assumptions need to be met for causal identification. One is that what the main authors for this approach call excludability, which means there should be an absence of any collateral events that could also have an effect on your outcome variable. So for instance, if there's, again, sticking with terrorist attacks, there's a terrorist attack, but maybe the next day national elections are happening. It's quite difficult to disentangle those effects from each other. So in an ideal setting, the context is quite calm and there's just this one treatment event, which is already, I would say, quite a strict assumption, given that the political environment is quite dynamic. And also there should be no time trends in the outcome variable. So for instance, consider you want to assess the effect of a campaign event on political involvement. Chances are high that in an already ongoing campaign, there might be a time trend in political involvement that is already increasing, coming closer to election day, just as one example. And also the timing of the event should be truly exogenous. So it should be, first of all, unexpected, that there are little to no anticipation effects, but also it should be exogenous in a way that, consider, for instance, we take a political scandal as the treatment event. It could be that media outlets know of that scandal, but they wait to spread the news until there's a very strategically clever point in time to actually drop the news. Then it's quite difficult to argue that the timing of the event is truly exogenous. Another assumption, which will also be quite important for the case at hand, is that of ignorability, which means that it should be as random as possible whether people are assigned to the treatment or control group. So the timing of survey participation should be random, which is very hard, if not impossible, to perfectly meet, because we know that people differ and that people who respond very early in the survey field time differ from those who participate very late in the survey field time, for instance. And also many data sources that are often used for that design, like large election studies or European Social Survey, for instance, they have multi-stage sampling where people in certain regions are interviewed or invited before people living in another region, which is certainly not random. And at the same time, the difficulty with this design is that given that it relies on an unexpected event, almost no data is collected for the purpose of studying that event, which means that it makes sense to rely on those big surveys with long field times and so on. Another assumption is that it should be justifiable to assume that everybody has actually received the treatment, which I would say, for instance, in the case of terror events, is quite easy to justify. However, it would be much more difficult to justify that a whole nation is aware of some very local scandal that has been going on. And finally, another assumption is that there should be no post-treatment bias. Meaning that, for instance, if you want to take a look at heterogeneous effects of the event and you want to divide your post-treatment sample or your sample in general by, say, partisanship, then chances are high that if you assess the effect of a campaign event, this could also affect partisanship. So your moderators should be unaffected by the event. And if those assumptions are actually met, then causal inference would work, as I have shown in the previous slide. However, given that those assumptions are rarely ever met, I argue that the causal effect that we have in our average treatment effect does combine the causal effect of the event, but also something that I call the compositional bias, because people in the post-event sample differ from those in the pre-event sample in a way that they could actually bias your event estimate. And this compositional bias, I formalize it in a way that it reflects the difference in the outcome variable that we would observe among the post-treatment sample between the actual post-treatment sample that is participating in the survey under the presence of the event and a post-treatment sample in a counterfactual hypothetical world that participates where no event has happened. So this is the sample that participates under the actual presence of the event. And here on the right-hand side is the post-treatment sample in the counterfactual world. And just to clarify this, ideally in the post-treatment sample, this here would be Y1, because it's the post-treatment sample. However, I wrote it down as y0 to make sure that this difference should reflect the difference in y that cannot attribute it to the event. So it's only the difference in y that can be attributed to compositional shifts in the sample. Okay. Are there any questions so far regarding that? Okay, because departing from that and knowing that those assumptions that I presented on the previous slide are most likely to be violated in a flawed world, I propose a framework that consists of three main steps to address compositional bias in the unexpected events during survey design. And compositional bias, first of all, regarding factors that are observable, like social demographics and mostly time invariant characteristics that are usually also by default covered by larger data sets. And that could be ideally statistically controlled for, but also compositional bias that is unobservable, because it could be that the samples differ in ways that we cannot observe or that are not observed in the data, but that then still affect the outcome variable. So as a first step, I propose to just get a baseline setup, which consists of following the unexpected event during survey design best practices that have been well established in the literature, with the aim of getting a baseline model, finding a good systematic component, good control variables, maybe also including fixed effects to control for things like multi-stage sampling, finding a good baseline model to work with. And once you get a good baseline, the second step is to address observable compositional bias and ideally control for it completely. And that includes conducting a range of robustness checks and weighting, bandwidth reductions. I'm going to guide you through the detailed steps with the running example. But for now, just to give you an overview. And the goal is to have an estimate of the events effect that is as free as possible from of observable compositional bias. And once that's sorted, we can actually focus on unobservable or unobserved compositional bias. And here, of course, the difference or the difficulty is that it's impossible to really quantify how big compositional bias based on unobservables is. But what I propose is to conduct a range of sensitivity analysis to at least quantify how strong the influence of an unobservable compositional bias would need to be to threaten the causal conclusions that you obtained from the previous two steps. So to gain an understanding of how likely it is that your conclusions are invalid because of this unobserved compositional bias. Okay, before diving into the example, are there any questions? Any questions on Zoom? I guess you will let me know. Okay, great. Then let me introduce you to the example we are going to use to go through all of the steps of the framework. And that is the Charlie Hebdo terrorist attacks in Paris in 2015. And yeah, I'm pretty sure you are familiar with that. That was like a large-scale terrorist attack. Many people were killed. So it was a pretty, like, without a doubt, a terrorist attack of nationwide or even global reach and prominence. And luckily, if you want to say so, there was an ESS survey in field in France. So the outcome variable is satisfaction with government to reflect a typical rally round the flag effect. Also, this case has just been like extensively studied regarding a rally round the flag effect. So I think it's also a nice, first of all, it's straightforward. A terror event is very clear cut. We can keep other sources of bias at bay by excluding any anticipation effects and so on. And also, I would say it's a nice test of established literature and an established effect. I would say it's quite intriguing to figure out, is it actually such a law-like character that after this event, government approval has like peaked so much, or is there some compositional bias going on? You'll find out in a second how robust those established findings are in the literature. So I'm using government satisfaction as an outcome variable, recoded to from 0 to 1. And conducting the first step, I estimate two models. One is a naive model, what I call it, that simply includes the treatment indicator as explanatory variable and region level fixed effects, because the European Social Survey has precisely this multi-stage sampling to control for differences between the regions. And the second model I estimate is what I call a time model that interacts the treatment indicator with a running days variable, where 0 is the day after the attack. So what you see here, the effect that you see is the effect on the day right after the attack, to gain an understanding how quickly the effect kicked in. And in both cases, you see, 0 is here, it's quite on the margin. You see there's a significant increase in government approval for this baseline model. So a first indicator that there seems to be this typical rally effect going on, which I would say is also unsurprising, knowing how many papers have identified such an effect for precisely this case. Now, to start addressing observable compositional bias, the first step I propose is to reduce the bandwidth of days around this treatment attack in that case, knowing that very, very early respondents might systematically differ from very late respondents. So step by step, I restrict the sample and reduce the bandwidth of days around the attack. And to get an understanding of how much the bandwidth can be reduced while still maintaining sufficient statistical power, I suggest to just conduct like a pretty simple power analysis. And you see here, for different levels of change in your outcome variable or like effect sizes to be detected, the smallest possible bandwidth is around 8 days, where we still have sufficient statistical power. So this gives me a guideline to know, okay, let's look at different bandwidth from the full sample up until a narrow sample of around 5 days plus minus around the event. And before rerunning the models, I also take a look at just descriptive statistics for those different bandwidths for different, most likely time invariant variables. So social demographics, where there are reasons to assume they are unchanged by the event, for instance, voted last election, most likely doesn't change by a terror event. And then also just because it's interesting to see, here's also a variable included with interview attempts, which is of course higher for treatment group respondents. They have been contacted on average more often until they actually participated, which is another indicator that survey participation timing wasn't completely random. But the main takeaway from this slide is that there are some differences between treatment and control group. For instance, the treatment group respondents tend to be a little bit younger. They tend to be slightly more educated. And those differences do not really change when we narrow down the bandwidth. The uncertainty increases a bit for also just statistical reasons because the sample size decreases, but it's not that we can actually perfectly, let's say, eliminate those compositional differences by reducing the bandwidth. So another measure to take is to conduct so-called entropy balancing and to re-estimate the model. So entropy balancing is a procedure to weigh control group observations in a way to match the treatment group distribution of certain variables, which then doesn't precisely give you the average treatment effect anymore, but the average treatment effect among the treated. So it's a slightly different measure we obtain. And typically you include social demographics as variables to balance on for the main reason that they are most likely unchanged by the event, because we want to avoid post-treatment bias. And it makes sense to include those where we expect an effect on the outcome variable, but maybe also on survey participation. Yeah, and as I said, focus on time invariant covariance. There might be cases where it might make sense to also consider or test weighing on potentially time variant variables, but as a default, I would suggest to just keep it clean and focus on social demographics and time invariant variables. Now, with reduced bandwidth and entropy balanced samples, you can re-estimate the models. And that's what I did here. You might notice from the full sample, it doesn't go all the way down to the 8-day bandwidth anymore, as indicated by the power analysis, because at some point the entropy, like the procedure to obtain the entropy weights, might restrict how much you can narrow down the bandwidth because it just stops converging. So find, let's say, the narrowest bandwidth that is possible, either with power analysis or the convergence of your entropy balancing model. But the main takeaway in substantive terms is that if we, by this, control for observable compositional bias, the results remain mainly unchanged, which is nice, I would say. So it doesn't seem to be so harmful. In no cases does the effect size change, and in no cases does any systematic effect become non-systematic, which again supports that it seems to be the case that there was an actual rally round the flag effect going on after the Charlie Hebdo attacks. Okay, with that, we have kind of sorted observable compositional bias. Now, before continuing with unobservable compositional bias, are there any questions, any thoughts, any clarification points? Okay, then continuing with what to do with those unobservable compositional biases. One thing, what I suggest starting with is obtaining a measure that's called the robustness value. And the robustness value is a measure that quantifies how strong a potential unobserved confounder would need to be to meaningfully change your effect. And this robustness value is the minimum proportion of variance that an omitted variable or an unobserved variable, which technically is nothing else than an omitted variable, would need to explain simultaneously in the outcome variable and also the survey weights, or in our case, the entropy weights. So it's kind of an R squared for the outcome variable and the survey weights. And you define a specific threshold of bias. So what I do here is I define the bias threshold as reducing the causal estimate entirely to 0, which is certainly conservative. You could also be more strict and say, okay, but I'm also concerned already if that bias would reduce my estimate or half my estimate. So that's something you define yourself, where it also just makes sense to look at the specific case you're studying and adapt it accordingly. For instance, consider an outcome variable, like a binary outcome variable, and you're assessing the race between two candidates. Then it's not really sensible to define the bias threshold as reducing the effect to 0, but it might make more sense to define it as flipping from one side to the other, so at 0.5, because then the outcome would change. So that's just something to adapt to the case under study. And this robustness value is interpreted in a way that it's bound between 0 and 1, and values closer to 1 indicate a very robust effect, because your omitted confounder would need to explain a huge portion of variation to actually threaten your causal conclusion, whereas a robustness value closer to 0 indicates that already kind of a weak confounder, or a confounder that explains just a small share of the variation in outcome and survey weights, could already overturn your results. And on this plot, you see this robustness value for different bandwidths, and also for different proportions of different shares of bias. So let's stick with the full sample. For instance, you see that here on the right-hand side, for an omitted confounder to reduce the bias, or to reduce the estimate actually all the way to 0, it would need to explain almost 3/4 or more than 3/4 of variation in the outcome variable and the survey weights, which, without knowing the context and effect of observed variables, is quite a huge portion. I mean, we all know R-squared values of statistical models where we assess like real-world problems. This is huge. So we can say this is a pretty robust effect in that case. And also, I would say it's quite intuitive that it's lower when we reduce the sample, the bandwidth, and therefore also the sample size for statistical reasons, where, for instance, under the narrowest sample of 16 days, already less than 1/4 of variation that would be explained by an omitted confounder could threaten your causal conclusion. So this is nice, I would say, and gives us a nice hint at the robustness of the effect. But at this point, it's pretty difficult to contextualize it, I would say, because we don't know how much variation would actual observed variables explain. We don't know the context of the model. And also what this value doesn't do is it doesn't distinguish between variation that is explained in the outcome variable or the survey weights. And it is certainly possible that a confounder could explain a lot of variation in the outcome, but only very little variation in the survey weights. So this is not necessarily symmetrical. So to understand that and to put this in context of observed covariates, we can take a look at so-called contour plots. So contour plots look like this. where on the x-axis, there's a measure called alignment, bound between -1 to 1, which is basically a correlation coefficient. And it shows a correlation between the error in the weights, so the entropy weights we used in the step to adapt for observable bias, and the outcome variable. And on the y-axis, you have the explained variation in the entropy weights by the omitted confounder. So this now allows us to distinguish how much an omitted variable would affect survey weights and the outcome variable. And then you see different variables that are already included in the model and also used for entropy balancing to gain an understanding of their effect and to put the threat of an omitted confounder into context of those observed variables. Because then here, that shaded area is the so-called killer confounder area, which I always think specifically with the Charlie Hebdo example and terrorist events, it's a little bit unethical, but that's how it's been established in the sensitivity analysis method, and I just adopted it. So this area indicates if the effect or the influence of an omitted confounder is located in that area, then your causal conclusion would be threatened. And again, threatened to the extent of with a threshold you define, which is still reducing or biasing the estimate to 0. So in that case, we see, considering the influence of observed covariates, it seems very unlikely that an omitted variable would actually overturn your causal conclusions. And for the narrower bandwidth, it looks pretty similar with 40 days. And then slowly but surely, if we narrow down the bandwidth to 20 or also 16 days, this killer confounder area incrementally comes closer to the observed variables, which also makes sense for just, again, purely statistical reasons and statistical power. But still, for this Charlie Hebdo example, it doesn't look like there's a realistic threat of unobserved compositional bias, completely biasing your estimate to 0. So overall, now having gained an understanding of the threat of unobserved compositional bias, I would conclude that this established finding of a rally round a flag effect after those attacks seems to be quite valid and seems to be pretty robust and not very sensitive to compositional biases. I'm going to leave it here at the moment to open the floor for questions. And depending on the time we have left, I can also guide you through a series of replications I did to apply this framework in a slightly broader manner. Could also introduce one more measure that I find quite handy that kind of simplifies the information we get from the contour plots. But for now, I would open the floor for questions to clarify things before proceeding.
Questions?
Also, if you don't have any, I'm happy to continue if you want to digest things a little bit more, but I don't want to rush through things before clarifying. Yeah.
I can start and give everyone else some time to think of questions of their own. So 2 things I found myself wondering. The first, at a more conceptual level, how does the bias, the compositional bias that you emphasize, relate to this idea of sample selection as collider bias? So an idea formalized by Schüssler and Self in a recent publication in Sociological Research and Methods, where they essentially argue that the main bias that occurs is between both the treatment, which in your case would simply be time, right, and the outcome of interest jointly influence the process of sample selection. So would this conceptually be equivalent to that? And the second question regarding this method here, the sensitivity analysis. I mean, usually what these methods do, right, as also represented here, is that they benchmark the bias induced by one hypothetical confounder against the isolated effects of observed potential confounders. But I wonder, what about the totality of omitted confounders? So could we kind of benchmark this against some sort of linear or nonlinear combination of observed confounders?
should I reply right away or? Maybe regarding the first one, like just from hearing what you said, intuitively, I would say, yes, this is equivalent, but it's not that I have the paper and their conceptualization fresh in mind. So I would actually need to take a look to fully understand where it might differ. But from what you said, I would say intuitively, it follows the same logic. And the second thing, that's something I'm super intrigued by. And actually, what I kind of, the cliffhanger I gave with that other measure I'm going to introduce is at least something that benchmarks the potential bias influence against one selected covariate and not these, I mean, those are not collected, but like the several ones. And I've also been thinking about whether it's possible to kind of, in a way, add up or summarize the influence of all the observed variables to benchmark it against an unobserved confounder. But I don't have so far I don't have a solution, but I have a long list of to-dos and follow-ups for this. So it's nice to kind of hear that you came up with similar thoughts. But for now, I can't give you a solution or an answer for that.
Very interesting paper. I was wondering, apart from the terrorist attack events, what type of other events have you seen in the literature, or is there like, can you apply this because you have so many strict assumptions? And related to that, also with regards to the survey, like how granular would the survey need to be? I guess ideally days or as frequent as possible, but could you say that could be applied as well if you have more like broader time intervals?
So the first question, I guess you mean how the unexpected events design has been applied to many different cases. Of course, one super prominent group of events is terror attacks. So from the whole, also kind of like international relations direction. But also events that I intuitively would render as less unexpected, like also campaign events, election outcomes, speeches. So I would say among those assumptions, that of anticipation is relaxed the most, just by knowing the literature on that method. And I think it's, in the end, it's also a little bit of a conceptual discussion or question how much you can justify to relax that assumption. Because just judging by how those analyses look like, I would say they look quite neat in a way that many other assumptions are met. And I would assess it's justifiable to still speak of causal inference with that. But yeah, I would say maybe another name that doesn't include the unexpected event might even be more appropriate, judging by how it's been applied in the literature. And the second question, can you remind me?
The timing of it.
The timing, yeah. But this is just out of my experience when I was looking, because I think large part of applying this method is searching data and looking for data, or also looking for specific events, having a group of events or family of events in mind. And oftentimes it's difficult to find data sources that have some kind of balance in the timing before and after the event. So what happens often is that the event happens the day before the survey ends, and then you just have too little observations in your either the treatment or control group, but in one of both. And I would say theoretically, it's not necessarily an issue if you don't have the granularity of days, but I would say that really depends on the type of event and also your overall survey timeframe. So for instance, if it's an event where you expect a very immediate, but maybe also short-term peak or change, let's say, but then you only have the next observation 5 days after, I think that's quite difficult to identify a solid effect. I think it just really depends, but I wouldn't say there's a strict rule.
Thank you for the presentation. I think it's really nice, very well done and very interesting. As far as I understood the argument, any compositional change pre and post event is attributed to the event itself. And the argument behind that, I think, is convincing, and the way you presented it is also convincing. But I think an already well-known fact about surveys, especially quota sample surveys, is that there's just a change over time when which groups are contacted. Specific quotas that are more difficult to reach will be interviewed later in the fielding period, and this leads to variation over time, who is early in the survey or later in the survey, which will then also correlate with pre versus post event, but will not be caused by the event itself, but just by the way how the survey is rolled out or how willing different groups are to answer to a survey. Is this something you thought about? Is it a deliberate argument? Well, it's a deliberate that you do not talk about this? And I think the consequence is similar. The problem that arises from it is similar. I'm not sure whether it's important to disentangle it empirically to solve the problems of disentangling, whether this is, so whether a specific share of the compositional change is caused by the way the survey was rolled out or by the event itself.
Yeah, that's a fair point, actually. And it's something I've been thinking about quite a lot, because, I mean, the steps that I use to control for those observable sample compositional differences, they are already also included in the best practices for the design, precisely to control for, let's say, any survey design related factors where people in the treatment group might differ from those in the control group. And I think, well, first of all, conducting those steps to then also address compositional bias that might be caused by the event leads to the same, like it's the same measure to address both problems. And I don't know whether it's actually possible to clearly disentangle them, because I guess the same or similar variables, social demographics, for instance, could be the ones where the samples differ, and that could either be due to design-related factors, but it could also be due to the event itself. And that's, I kind of hinted at that at some point where I said there might be occasions where it might make sense to also use time variant or like less stable variables for the weighing procedure. And I think that's something where there's some leverage to address precisely what you say. Because I think there are cases where it might make sense to think about, okay, which variables do I expect to be affected by the event that you can include into the weighing, where you still have reasons to assume that you don't introduce post-treatment bias by including them. And I think that's a super difficult balance to strike. But I think that would be the way to start disentangling them. Because most likely, sure, an event probably rather affects time invariant variables, or renders people to be, I don't know, more democratically satisfied, and then they are more responsive. And this is just like one example. So I think that's a point where it would be possible to start disentangling them. Yeah.
Questions?
Yeah, two questions of the annoying type about could we also extend this to the first is panel data. So if you have a critical event in between two waves, obviously you don't have the problem as with the UESD design that the people answering pre and post the event are fundamentally different. But of course you have the phenomenon of who participates in which wave. And I just wonder if you've already reflected on how this changes the problem that you sketched today and the solutions that you presented to address the problem. And I have to think a little bit more about the second one, so I'll just leave it at this for now.
Yeah, that's also something I've been thinking about, like, first of all, an extension to other kind of data structures, but also an extension to other methods like RDDs, diff and diff, other structures of outcome variables, binary ones, and so on. Because so far it's quite restricted to this design and the linear outcome variable. And I think with panel data, the first, let's say this is quite like a problem-oriented answer I'm now giving. The first difficulty I see is how to disentangle normal attrition effects that just occur from those that we could actually attribute to the event. I think that would be the main challenge to have kind of a neat isolation of potential event-induced non-response. maybe we can talk about my thesis at some point, because that's kind of where I combine it also with another work or like another paper where I use panel data and precisely assess the effect of events between waves on like subsequent participation, where there are also patterns like that certain people become more unresponsive and so on. I think I would need to think about it, but it's on the list. But intuitively, I think it's possible to extend it, or because the assumptions are the same. Like, it doesn't make a difference whether you have one survey field time that is cut by the event, or whether you have two waves that are kind of like divided by an event and the same people participating again. Precisely knowing that within a person, it's also dynamic how responsive you are. Like, you don't have a fixed level of survey responsiveness. So I would say there are parallels worth exploring.
Can I follow up with this? I mean, it's something we don't do a lot with event studies, where we mostly look at how an event shifts the average level in an outcome. But we could, at least in principle, also leverage events to see how effects or mechanisms change, right? So how does the, let's say, relationship between immigration, skepticism, and far-right support change as a result of a terrorist event? Which, of course, complicates the whole thing a little bit, because then it's not just how does Y and time affect self-selection, but how does Y, X, and time affect self-selection? So is that something like an extension you've considered, and what are your thoughts on this?
Not that I considered it, but now that you mention it, it's very appealing.
So like, it's like postdoc project.
Yeah, because I mean, in the end, like, this is super simplified, but in the end, it's just one more step in between, right? You do one more step to obtain your outcome variable, which is here just a univariate distribution. But then in that example would be the relation between two or multiple variables. That's appealing, yeah. Yeah, but I haven't thought about it in that way so far. But I think it's possible, yeah.
Questions?
Okay.
You can talk about,
yeah, sure.
Here, as you mentioned. So.
Yeah, let's conduct some replications. So yeah, because after conducting this, I thought, okay, it's nice to have one example to run through these steps. But it would also be nice to see whether I was still a little bit intrigued by whether some established findings are less valid than they seem to be. Kind of doing some detective work. So what I did is I decided to stick with terror attacks and rally-like outcomes, again, for the reason that rally events are quite clear-cut and it's easy to keep other kind of biases constant. So for those replication analyses, I did a search for peer-reviewed journal articles on the effect of terror attacks on rally-style outcomes, using the UESD approach and being published after 2020, just because that means they can follow those best practices that have been established in that year. And then, of course, I wanted to have replication data, or at least enough explanation in the paper about how models were built to replicate them in the way they were originally published in those studies. So I ended up with precisely 4 studies that overall cover 15 cases, because some cases overlap. 4 different outcome variables like trust in politicians, satisfaction with government, prime minister approval, and also trust in politics, mostly in Europe, 1 in Africa with Afrobarometer data in Nigeria. And overall, they cover 3 different data sources. Most prominently, it's ESS data. That's just, I would say, the winner for this approach, just because it covers a large time frame, it covers many countries, and it usually also covers the political variables that people are interested in using that approach. Now, as a quick run through step 1 with the baseline setup, and also step 2 to address observable compositional bias, you see here an overview of the base estimates for each case. On the left hand for the full sample, on the right hand side for the case-specific narrowest sample. And then also in this lighter blue, the entropy balanced estimate. And I would say there are a few takeaways. First of all, unrelated to this methods perspective, but I find interesting in substantive terms, is that Harris 2015, up here on the 3rd row, is kind of an outlier with this positive effect. And I find this is interesting to see in direct comparison to those other cases, because in this rally literature, there's also a kind of a debate going on. Because on the one hand, it's always framed as this law-like thing that after a terror attack or international crisis, government approval must surge. But it's heavily US-driven, those findings. And there's the debate whether this is actually transferable in this law-like manner to the European context. Some say yes, and always refer to Paris 2015. Others say no, we rest this assumption on Paris 2015. So I think it's quite interesting to see that it's less of a law-like thing than you might think of. But this is more like in substantive terms. Other than that, there are basically no cases where entropy balancing creates a significant change. Here in Tel Aviv, a non-significant positive effect turns out to be statistically significant negative effect through entropy balancing. But other than that, it doesn't look like observable compositional bias heavily altered those results. Now, it would be quite extensive, let's say, to have contour plots for all those cases. So what I leverage is another measure, which is the so-called minimum relative confounding strength, which is also established in connection to those sensitivity analyses. And that's a measure that assesses how strong an unobserved confounder must be relative to some observed covariate, a benchmark, kind of what Dennis also mentioned earlier in one of your questions, to bias the estimated effect. Again, bias to a self-defined threshold, and you could basically pick the observed covariate that you want to benchmark the unobserved confounder's effect against. And what I do, I extend this a little bit and introduce the so-called MRCS max, which reflects the value of this MRCS value in relation to the most influential observed covariate, to kind of have a hard case or like a conservative case to know that like how much or how strong the influence of an omitted confounder would need to be related to the strongest observed covariate. And what this does, it basically collapses the information of the contour plot into this single measure. We lose, of course, a little bit the distinction between effect on the outcome variable and effect on the weights, but it kind of gives you an understanding of how realistic it is that an unobserved confounder would threaten your causal conclusions. And it's interpreted in a way that any values above 1, like it could be negative or positive, so absolute values above 1 indicate that an unobserved confounder must be more influential than your benchmark, and values below, absolute values below 1, indicate that already like a portion of that observed covariates effect would threaten your causal conclusion. And you see here an overview for all those cases. I didn't indicate, like those letters give you the different outcome variables, but I think for now it's just interesting to see that here the MRCS max for the full sample and then also for the case-specific narrow bandwidth in very few cases is small enough to indicate that your causal conclusions are very likely to be threatened. Like for instance, again, the beloved Paris 2015 case, an unobserved confounder must need to be around 85 times as strong in the effect on the outcome variable and weights as compared to the variable of having children, which seems to be quite influential, to overturn the results. Or another example that's interesting. Yeah, I mean, let's just take the second row already. Manchester 2017, the Ariana Grande concert, which was also a case where studies have found a rally effect. An unobserved confounder must have an effect around 8 times as strong as having a Labour Party ID. And the effect of having a Labour Party ID is quite strong. So that's also, even though the value is much lower as compared to the Paris case, that's also an indicator of a very robust result. Whereas other cases, as for instance, here one case in Russia, already like an influence that is quite similar to that of an observed variable would overturn your causal conclusions. So those are just a few examples, but I think they kind of give you a sense of what this measure might tell you. Are there any questions on that so far? And that's, of course, also a measure that could already be conducted, like if you just take a look at a single case. I think it comes in handy if you have a comparison of many cases, but it's also expressive if you just apply it to one single case. Okay, then zooming out. First of all, the point I made in the beginning, I think it's very important to just keep in mind that non-response is not necessarily problematic. It's not by design a problem. It just really depends on the correlation of non-response with an outcome variable. And as soon as you have a correlation between responsiveness and the outcome variable, you should be very cautious about potential biases. And then the understanding that certain political events and not only changes in people's very narrow contexts could also spill over into the domain of survey participation and introduce biases, I think is important to keep in mind how likely it is that your causal inference is maybe not as causal as you might think or might wish for. Which basically this sums it up that in event-focused quasi-experimental designs, it's important to keep in mind that the event might not only affect your outcome variable of interest, but might also affect the survey participation process and produce those compositional shifts. And while it's quite easy to effectively address observable compositional shifts, we just unfortunately cannot quantify unobservable ones. But I hope that with this sensitivity analysis, I kind of show to you one way to at least gain an understanding of the likelihood of such bias and how likely it is that your causal conclusions might be threatened. And with this, I thank you a lot for attending both online and here, and I'm happy to address any remaining questions, hear feedback, hear your thoughts on this. If there are any questions left.
I have one minor question. Non-response bias is, and as you have shown, I mean, this is all variable specific. Like you look at one variable. Have you done that also to multiple variables? Like, and of course, it needs to make sense theoretically, but just curious.
Just like bivariate distributions, for instance.
So I mean, so for you have this kind of government support, right? And other like politically variables.
For that specific case, I checked ideology, for instance, left-right ideology. Not that I can, like, to be honest, spontaneously recall what the results were, because I mainly focused on the rally effect. But in principle, of course, it's possible to apply to different kinds of variables. And then also, and this is kind of pointing to what Dennis suggested, to not only look at univariate distributions, but to also assess in how far non-response bias might also affect the correlation or association between variables. Because I think that's an interesting path, because I don't know if that's only my perception or just common sense, but I feel like there's a at least implicit understanding that bivariate distributions or correlations should be more robust to phenomena like non-response bias. But I think it's worth testing whether that's actually the case.
Thanks again.
Yeah, thanks for having me.
I mean, I guess you're around for questions. The next event in the Social Science Center Lab would be a talk by Andreas Küpfer from TU Darmstadt and University of Birmingham on politics in action, studying multimodal data from local meetings to national parliaments on March 11th. Thanks for joining and see you next time.
Thank you.